Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have an XSS to RCE chain in the Mailspring email client, a .NET CRLF injection, and a GraphQL based MFA bypass. First, though, we have a post by Portsquigger, which hit the feeds but was unpublished, though Z archived it and thought it was interesting, so we're going to do a bit of coverage on that. Though, forewarning, because it was unpublished, we don't really know why. If it was due to some technical error or something, we might not catch it, and just wanted to give a bit of a warning there. But yeah, so you thought this was interesting, Z? I'll let you get into it.
Yeah, right when I saw it, I had a feeling about where it was going to go. Like just from the title here of well, maybe I should actually pull up the title. Have to scroll a little bit, but making desync attacks easy with trace. And basically, as soon as it was mentioned, I all of a sudden kind of had a click on like how you could use trace with desync attacks. And he goes far more detailed into it here. But like you said, this post was retracted, well, not necessarily retracted, but was taken down, and then I had to get a cache of it and then archive the cached version of it. So we also don't have like any images that might have been in this. The formatting is terrible to try and follow, especially for HTTP requests here where we don't have new lines showing for any of them.
You're
Kind of
missing the
hinders
new lines in
readability.
HTTP headers. Yeah, it's
Yeah,
not
it
great.
definitely hinders a few things there. Nonetheless, I'll take an attempt to explain what's going on with this as I understand it. But since I don't know why it was retracted, because there isn't anything here that's like, oh, this host might still be vulnerable. This does just seem like some novel research or at least some idea on exploiting the desyncs without mentioning a specific host. It's unclear why they took it down. So it could be the case that while this kind of works and it seems to work in my head, maybe it just didn't work, or more likely, I'm suspecting is just it was published early. I noticed that most of their posts come out on like a Monday or Tuesday, and this one was a Friday post at a different time. So I think it could have just been like an scheduling error, and they retract it for that, and it'll probably come out sometime this week. So we're just getting at it a little bit early rather than there being something substantially wrong with it. But do want to offer that caveat here because there is the chance that there is something kind of broken here that I'm just not getting because I'm not actually playing around with this. I'm just using my understanding and kind of reading what they're presenting here. So, with all of that said, what is trace? I would forgive people for not really having played around much with trace these days because you just don't see it. There used to be this old attack called cross site tracing, where it was a way of when you had HTTP only cookies, you could use like if you had a cross site scripting vulnerability, you could then use cross site tracing potentially to leak those HTTP only cookies. In theory, so I should also mention what trace is, I guess. Trace is another HTTP verb, been around for a long time. So it's kind of like get, post, put, delete, all of those normal verbs. Trace is another one meant more for debugging, I think, where what it would do is you send a trace request and the response is supposed to be just your entire HTTP request as the server received it, reflected back to you in the body of the trace response. Is supposed to strip any sensitive information out of there. Realistically, a lot of implementations wouldn't necessarily know like which cookies to strip or may not strip cookies at all or things like that. So not all sensitive information would actually get stripped before sending it back. Implementation dependent there, but that's where the cross site tracing thing came in because you could use XSS to send a trace, which you can't do anymore, by the way. You'd go through cores, but could do that and you'd be able to see the cookies because that was part of the request that was sent. So there was that sort of attack, way back, but haven't seen much with it now. But yeah, so with request smuggling here, it basically means you're able to control in theory, a lot of content in the response of something. So with smuggling, you smuggle the request in there. You get that desync going on when it comes to like what the response is for and who gets what response or what request matches to what response. Could be useful with something like cache poisoning to basically inject or get some content in there with a lot of control being treated as the response of something else. Although it should be known that trace directly and the trace response will have like the I'm not sure if they show it here. I think it's like message request. Oh, message HTTP. Yeah, so it has a really weird content type. Not all that useful like for XSS, but I could immediately when I saw that, I started thinking about like, okay, yeah, that does give you a lot of control. So how are they using it here? And so starts off just leading into the story. They're working on some bug bounty program, find request smuggling, report request smuggling, but the program kind of rejected that as well. How are you going to actually exploit the smuggled request? Or what are you going to do with it? Turns out that was harder than they thought because they didn't have some of the usual gadgets that might make this easy. So they started exploring some of the options with Trace. Specifically, they ended up combining kind of Trace with a head request. So if you kind of got the example here, and this is, bad formatting for the reasons we already talked about. But if you had your get request go through and then you're going to smuggle from that, and he does talk about his the actual desync primitive that he had by smuggling in a transfer encoding header and all of that. You can read the post for some of those details. I just kind of want to focus in on this trace aspect. But he would smuggle in a head request, and then a head request normally will respond just with all of the headers, given the name, as if this were a get request. And importantly, that would then include like a content length header to say, like, okay, this request would have been this big and this much content would have been in it. And as you can see in the second bit here, that content length may have been, well, I guess it's maybe not the best example of the head thing here, but that content length, since it's a head request, it doesn't actually include any content. There is no response body. And that's where the smuggled trace comes in, because its response is then kind of going to exist there and it's going to fill in for the smuggled head. So the head comes in saying like, oh yeah, I've got a content length of 165 bytes. And then it just stops there because that's how head requests work. So then the trace's response comes in. It doesn't know this is a new response, just like, okay, this is the rest of it as it reads those 165 bytes of the trace as being the body to the head request, which in their example here, had a nice content length, so they could potentially get cross-site scripting there.
Sorry, I think you meant content type, but yeah, because that's the text HTML type. Yeah.
Yeah, what did I say?
You said content length, so
Oh,
that's why I just
sorry.
wanted to jump in quickly.
Yeah, content type of text HTML. So, any JavaScript injected from that trace could end up being reflected, and because of the because of the content type header, will actually be executed as HTML. There's one other thing I should note here is that they are injecting this as part of like a header. And that just comes down to how Trace normally ends up working. A lot of systems, if it even does support Trace, will end up not allowing actual bodies in the trace request. I'm not sure if that is by spec or not. I don't think it is because I do know some servers will allow bodies. Either way, a lot of times you're limited. So that's why this is happening, kind of using headers rather than the body of the actual trace. But if you do have body support, it's much easier. And I guess on the note of support, I should also mention that trace often is kind of blocked, especially by like, a firewall might be saying like, don't allow these traces through. But since you are smuggling requests, you very well may be able to get a trace through, even though it seems like trace isn't actually supported. A fair number of servers do support trace just by default, as it's one of those easy things to quickly implement and, is useful in a sense for debugging setup. So does exist there, does have some support, even if you don't see a use too often, and it is often blocked, but again, the smuggling may allow you through and may allow you to actually do something, or may allow you to get that request through, even though it's otherwise going to be blocked. So
It's kind of
carrying
funny
on,
that trace is enabled on like the back end and stuff, but then it blocked at the proxy level. Like you think there would be an effort to try to block it on both sides, but yeah, sorry, go ahead.
that would be ideal to block it on both sides, but it also makes sense that somebody who, like somebody who's caring about the network level and not the application configuration, hey, let's set it up on the firewall right on the edge here, trace requests, they get dropped. We're not dealing with them. And then they need to know their firewall config, something that they've likely worked with a lot and know. versus whatever random framework an application is using. Or if they're lucky, they're using like Apache or like just a standard server that has the common configuration. But because of that, you'll see a lot of variations. It's a lot
That's fair.
easier just to do it at the edge, at the just firewall layer, though. And that way you don't have to play like you don't have to
Play
run around
whack-a-mole.
finding you don't have to go and find every single server that's running it. You just block it kind of later on. It makes sense to me. Less ideal so cases like this, but it's a pretty fair trade-off still, I think.
There is a reasoning, yeah.
Yeah. So anyway, with all of this, basically head plus trace gives you this ability to control a response, but what can you actually, or it gives you the ability to control some of the response. Again, a lot of time you are kind of being limited with headers there. But even being able to control that response is what are you going to do with that? In this case, they were in a situation where there was client isolation. So you couldn't make your response go to some other random user. And even worse for their use case here, they also come find any requests. In the example we had here where content type was text HTML, they couldn't find any requests that were going to be cached that would also have that text HTML. So they could basically only attack themselves. The option they were looking for there was, could they get any sort of cache poisoning? If they could have a request that was going to have the content type text HTML, and then they smuggle this request, they smuggle the trace in there so the response to that isn't what was actually expected, and they have kind of arbitrary control over it. Would be great if it was cached, but they didn't have any HTML cases, so again, not as useful as it could be without any of that, which then kind of leads them more into from trace to response splitting here, this little section where I kind of already started touching on this, but when it comes to the content length, that head is going to have like some specific size of a request, and then after it's read that many bytes, the next bytes it gets, it's going to, if it doesn't matter, if it doesn't look like an HTTP response, it's just going to reject it, close the connection, because like, what's going on here? Something's obviously happening in errors, something's going on. And it's usually going to have some problem with that. But if it does match what it's expecting for a response, then, it's just going to treat that as another response that came in. So from using that trace, you can now also inject a completely new response, and they go here to inject some cache control headers to say like, yeah, cache this thing for X period of time, and kind of have more complete control over the entire response, including the headers like the content type, the cache control headers, if those are going to be relevant for the caching, and of course the actual content. So they basically just take advantage of having a larger content length, or having a content length that having a trace response that is larger than the content length. Therefore, they could actually start smuggling in the next response. And then they can make that next response that gets matched up to it, and potentially get that cached and have this complete control over the headers thanks to the response splitting due to that misparse. So hopefully I've explained kind of what seems to be going on here pretty well. They do go into it a little bit more when, like the header aspect I was talking about, some of the differences in environments, so you can read for more information. I hope they do put this post out, because this does seem like a really cool technique that could be useful, because it is largely generic. So it does depend on trace, but doesn't depend on application level setups. It doesn't depend on having like the reflection in the page, as they kind of talked about, as they didn't have anywhere that gave them good reflection, or gave them that sort of reflection gadget that can be used, or like a concatenation gadget or anything. It's just a generic technique that you may be able to use to take advantage of request smuggling. Granted, it does depend on caching when you're going for the cache option there. So, there is that, but it does seem like a really cool technique. So I'm hoping they kind of publish this and I can maybe read it a little bit easier with the headers being formatted properly and stuff. But yeah, I mean, honestly, trace is something I never really considered joining with the request smuggling. Maybe others have. Maybe this isn't actually novel. I'm not I have no say on that aspect, but Trace has been
It's new
around
to
and
us, though.
I kind of forgot about it. Sorry, what do you say, Spectre?
Oh, I just said it's new to us, so it's
Yeah.
like, maybe it's not new to some other people, but yeah.
Yeah,
Yeah, no,
it's
it seems really cool, and it seems like tailor made for request smuggling due to the way the setup is, and like you said, where it's generic, it can be a good trump card to have in case everything else fails.
yeah, other things are definitely going to be easier and easier to understand, but definitely seems cool. I mean, I think it's cool research. I am hoping this actually lasts and there isn't like some fundamental problem here we're just totally missing. But yeah, I really like this.
So yeah, if the final post does go out and whatnot, we'll update the links for those of you, because yeah, like trying to read the archived link is kind of brutal to parse through. So uh, be warned, I guess, for those who like to check out the links outside of the show. All right, so we'll get into our next post here, which is a quite complex attack chain from Sonar against Mailspring, which is an email client app, and their attack chain ultimately pops calc, and it's based on a mutation-based XSS when rendering emails due to an issue with sanitization, which is a somewhat straightforward issue, but it takes a lot to exploit due to some defense in depth that's in place. So I'll let Z get into the specifics.
Yeah, and this one really stood out like from the start because it's a mutation based XSS. So, it's a category of XSS we've covered only a handful of times because it is relatively uncommon. And I don't know if it has a really clear, clean cut definition on what exactly makes it mutation based versus just like bad sanitization. So that's another reason why we probably don't see the term mutation cross-site scripting used too much here. But I'm just going to step through what goes on here because I think there is some fun to this. So first off, they're dealing with emails and all of that, so there is a lot of attacker or external content that's coming in going to be displayed, and they write their own kind of sanitizer for it using DOM parse. So that's just built into the engine. Like DOM parser is just what the browser's using to parse the DOM, so they're able to parse their own DOM tree out, and that kind of makes sense. You'll see here where code just parser, get the new DOM parser, generate a document from a string that they've received in, and then they call this sanitized node, which takes the whole document element and sanitizes it. So they have written their own sanitizer there, but DOM parser itself, I believe, is coming right from the browser. It's the built-in parser. And so it is parsing this. This is an example thing here, but somewhere inside this document will exist this SVG, or as I've learned, some people call them savages, which I kind of like.
I haven't heard that
but
actually, but
yeah,
it does
so
sound cool. So
well, the argument I heard was, if we're going to say ping, we might as well say savage.
if we're gonna say what, sorry?
Ping for PNG.
Oh, I don't like that either.
Oh, well,
But
then maybe you won't like savage, but I say ping, so uh anyway, I'm actually probably going to say SVG here because that's what I've always said. But anyway, so somewhere inside of the document, you've got the SVG. Inside of there, you've got the style tag. And inside of that, you've got this little bit weird looking A tag or anchor tag, which, standard A tag has a title attribute. And the title attribute has this end style tag and image source, but it's all, well within the quotes. There's nothing too weird going on there. So if you're parsing the A tag, that style and image tags are just going to be in the title attribute. There's nothing really too weird there. The problem comes in when it comes down to how things are getting parsed. So you might also maybe have had this click already, but it's inside a style tag. Well, styles usually have CSS inside of it. So why is it, parsing an A tag out of it? And that's because inside of an SVG, and it's similar with like the math tags, the content inside there, I believe, gets treated as it's called foreign content and gets handled differently when being parsed into the DOM tree than, would be if it was actually parsing it as as an SVG. Now, I don't know all the nuances with foreign content and parsing here, so I am kind of just taking Sonar's word on this, where it's parsed differently and it gets parsed as This SVG will be parsed as a style tag with an A tag inside of it, which you can kind of see that if it's starting to treat this as like it's foreign content, therefore it kind of treats it more generically, it would seem. I tried reading the spec on this, but I didn't really get into it far enough to understand exactly what's going on there, but it seems like it is just kind of treating it as, for this thing, we're just going to call foreign content. We're kind of going to parse it as like just XML, basically, and that's what it does, and that's how it treats it. And because it's in the SVG,
nuances of the style tag are lost, basically, because of it's treated as generic XML instead of proper DOM.
Yeah, like at this point, it is. It's not treated how necessarily it would be by like the actual SVG handler. It just gets translated into this DOM tree. And then this DOM tree that they've created is what's getting passed through into sanitized node, and that's what's being iterated over as they try and sanitize it. When they sanitize it, they will remove a number of things and replace them with span tags, but importantly, they will remove the SVG tags and replace that with the span tag. So they'll parse through here, and you can see the document how it's parsed by the browser here too. See, it comes like the SVG, the style, the A tag. They're going to take that SVG and they're just going to say, yeah, make that a span now because, we don't want to deal with this, but we want to keep any text content there. They actually have some reasoning if you read the code about why and what they're exactly doing there, but they change the parse that and make it a span. And then they continue iterating. So as they iterate through the tree, they see the SVG, that becomes a span, but then they're just going to see this style and this anchor tag because those are already parsed. They've already been dealt with and parsed to the tree. And so they're just kind of going to look through that. Okay, nothing wrong, and keep going. It doesn't see like the weird anchor tag, or it doesn't see this image tag that actually has a potential problem there because it's not parsing it, or it hasn't been parsed as that. And then once it's ultimately done, it takes that node, or it takes that sanitized node, just grabs the inner HTML effect. So it's basically turning it back into a string and returning that. And then, it ends up writing that out into the final document. And that's where you run into the bug, because what ends up happening is, I feel like they have a screenshot here. I'm just not seeing it. Yeah, I'm not seeing the screenshot I thought they had.
I think I might have brought it up. I tried to. I think the one you're talking about is where they have the console open with the CSS window.
Wasn't what I was thinking of, but it shows exactly what I want anyhow. So yeah, okay. Let's work with that one. You'll see here they've got the span tag that used to be the SVG tag, and then they've got the style tag, and now that style tag inside of that is just the left angle bracket A title equals, and then end style. So if I go back up to that original payload, it's kind of this part of it where like it's ending with the style
title
there.
Attribute is being defined. For those that are listening and can't really visually see it.
Good call. Usually I'm better about that. Yeah, so like it's basically reading the style attribute, but now style is getting parsed as CSS, which means it's not going to
content.
Yeah, it's not going to see that A tag with the title attribute in it. It's just like, what the heck are these characters? This is invalid CSS. Oh, here's the end of the style, which was inside of the quote. And oh, here's our next tag, image, source, and the on air with the alert. And so as it gets reflected that second time after sanitization, the mutation that the sanitizer made ends up, and kind of the permissive syntax of the browser ends up allowing this image to get smuggled in there, or, the XSS payload to get smuggled in, creating the actual XSS attack because of their sanitizer turning it into a span, but not properly accounting for the change in how that data will get parsed into the tree anymore. So I thought that was just a really cool XSS attack. Takes a little bit to get there. The idea is relatively simple, though. It is just the fact that the parser doesn't account, or basically doesn't reparse after it changes the way the style tag should get parsed. And that is a nuance that maybe wouldn't be well understood. Like if I were writing that, I wouldn't necessarily remember like, oh, I've changed out an SVG, therefore things need to be reparsed, because all of this could be different now. Like, I totally get why somebody wouldn't be thinking of that because it's not very intuitive, especially when the
Exactly. I
code
was about to say
isn't.
it's not like even with the payload in front of you, it's not really intuitive what's going on. Once you go through it, it's like, okay, that makes sense. Like it's fairly simple, but at first glance, it doesn't jump out at you.
Yeah. So yeah, this ended up landing inside of a. This ended up being reflected. When I say landing, it's getting reflected inside of a iframe that's sandbox. So they couldn't do much with the actual XSS there, but they did find that using like forward would get it reflected outside of the iframe on a new page. So with that little bit of user interaction, they go to forward the message. It gets reflected somewhere that's a little bit more useful, and gets reflected there. But there is a content security policy going on, which basically just the default source was a star or anything. And while they do have like a script source, overrides the default to be self and some other and the Chrome extension thing in there. Uh, Beyond that, basically, there was no override for the object source, so they could just use an object tag uh, to inject their payload to be run. However, from there, turns out there was a little bit more sanitization going on. They didn't actually get into what would happen exactly or why it was happening. Just the fact that if they put things inside of a signature, it avoided the second sanitization that happened. So that's where they were able to get their XSS from. They did take this all the way to RCE. They mention that Mailspring, it's an Electron application, so it has node integration true and context isolation false. So any XSS in like the main area of the window would just have very easy RC because they don't isolate kind of all the host stuff from the JavaScript running. But they were landing in a different origin. They mention here the XU in the origin of attacker.com, which blocks the attacker from accessing the parent window due to the same origin policy. So instead, they use the old V8 vulnerability, or could use an old V8 vulnerability. They mention also the potential for other one-day attacks to be used in order to basically just exploit V8 at that point. And also another thing that could be done would be CSS exfiltration, which they talk a bit about. I don't know. Most interesting part of this for me was just the XSS itself, the exploitation here. It has some gotchas with it, has some steps to get through, but I didn't find it too interesting. Although Spectre, when you introduce this, you seem to think I guess, post vulnerability, the exploitation aspect there was more interesting. I don't know if you want to add some comments there or not.
Yeah, I found it kind of interesting. So I'll elaborate a little bit on the RCE aspect because the other way that they went with was basically taking advantage of the file protocol because Electron's being used here. The UI is served over the file protocol. So their whole idea there was if we can get a custom file on the machine, mainly through attachments, they could get attacker data served from like the victim's origin, and that thus they could access a top window. And that could also be used for the CSP bypass because even though object source was a route that they explored where script source was allowed for the self, like they had it set to self, if you could get a malicious file onto the PC, they could also use that to execute code through the file protocol. So yeah, that's kind of what they were talking about there. And then the CSS exfiltration was for getting the random path where the attachments were placed in, because they did have a bit of that randomized path going on. So what I thought was cool was that the target application here had quite a few defense in depth measures. Like they had the content security policy, they did the sandboxed iframe for the untrusted content, they have the same origin policy and everything set up. Like it seems like they took a lot of good steps that made the attacker's life more difficult here. I think this is a good demonstration of how defense in depth can be effective at that. It's just some like slight errors in their policies or slightly permissive things in their policies that they were able to take advantage of. But I mean, original like on a lot of applications, I feel like once they got the XSS, that's pretty much where we would stop talking about it, whereas in this case they had to get past like 3 or 4 different barriers to actually take it to a full RCE, and I appreciated that aspect of it.
Yeah, and actually, kind of mentioning that point, even to get the XSS, they had to step through some hoops. This wasn't a
Yeah.
very straightforward XSS by any sense, because a lot of standard XSS payloads just would fail on this. It would look like it was secure, but you know, this one case, I don't know how this was found exactly. I mean, again, I know Sonar is like the static analysis tooling, but I am guessing this was not simply found because I imagine Sonar did not actually come up with the exploit on this one. I imagine they were more like, oh, this is being reflected. I don't know for sure. They don't call it out, so I will assume that. Because, yeah, this feels like a hard thing to spot in general.
It feels like something you'd really have to find through, like, it feels like it'd be a lot easier to find in dynamic testing, I guess is what I'm trying to say. So, yeah, it's an interesting bug. And like you said, like, the only thing you could really fault the target application for, really, here, like, Mailspring, that is just trying to do that desanitization, as they call it, where they change and interfere with the sanitizer's output. Like, that is something where we've talked about it before, where it's like, okay, well, when you're doing that, it's very error prone. Like, it's very hard to deal with that sort of scenario properly. It's better to just reject the content outright. But, when you're dealing with
Well,
things like
I,
emails, that's harder to do as well.
yeah, so I think one note on this one is that they've implemented it's their sanitizer that's doing this. It's not like they got something sanitized and then perform this weird span change. That's where I'm not sure this really fits how they present it as desanitization.
It is a bit of a
Because
misnomer in that way, yeah.
yeah, because this, as far as I can tell, I didn't look deeply through their code, but they do link their code. They do link like the relevant code here. Yeah, when you click on like built-in sanitizer, and there's think another place where it'll link to it. Yeah, the replace word here will link directly to their code, and basically like they're taking the DOM parser and they're messing with DOM parser directly and that output directly, but they're not really messing with the sanitized output, which I think is kind of what's going on with their other examples. Although, should clarify, I have not looked at these other examples to actually see what they were going on. I'm just going off of their description of it here as the act of changing and interfering with sanitizer's output. So it does feel a little bit different from that. And like I said, I'm not sure if I'd consider this like what we usually call a mutation XSS, but I can see why you could consider this a mutation XSS, because we are getting this change of context with this style tag getting reparsed and stuff, and that is kind of a browser engine thing. Their small change leads to this.
It's kind of tricky
Yeah.
to classify.
Yeah, and
So
I mean
it's fair.
mutation XS is not, I don't think it's well defined. Like it's not a super common thing, but it definitely caught my eye. And yeah, this is still, I think, a cool attack, regardless of what we
Yeah.
want to call it.
And one final thing I do want to call out is that, so like I was praising the vendor a lot here, saying like, they do a lot of these defense in depth things. Although this bug wasn't properly patched, because in the patch section, Sonar calls out that they tried contacting them in various ways, but there wasn't really a response. The only fix that was implemented was basically hardening the content security policy, so that object source trick doesn't work anymore. They set that directive to none, but you could still potentially take advantage of the attachment route by going for the script source self. So it's not fixed as well as you might like. So I did want to call that out. Maybe that'll change in the future, but that's how it seems to stand right now. So it seems like this chain is sort of still a 0 day.
Yeah, sort of. I will call out the fact that they're not doing like the node integration, like their whole not Chrome Electron setup, node integration true, contact isolation false. Feels like a bit of a risk just as is, because that makes the main thread very powerful within an Electron application.
Yeah,
Like
it really amps the impact up from taking that XSS to the RCE, which is a lot more dangerous. Yeah.
yeah,
Although, I mean, you do still have the where it's running the older version of Chromium, you could still get the code execution through that as well, through like a browser end day, but that's a lot more complicated to do.
Yeah, I at the same time with this, like, they do kind of need that access back over to like the host system. It's not like they can run completely isolated because of the attachments and the file system access and all of that. Or at least I don't
Yeah,
think,
overall,
I
I think they
mean,
did a fairly good job in trying to harden their setup, but it's just there's only so far you can really go,
yeah.
before it becomes kind of unreasonable. So, but yeah, that main bug with the XSS mutation based XSS does still seem like it's a problem. So, yeah, wanted to mention that. So we'll get into our next issue here. So this was a post by Security Cipher on Medium. This is just a quick multi-factor authentication bypass in an undisclosed app that got them a $600 bounty. And this really just comes down to the fact that there's multiple APIs being used here, including a GraphQL set of endpoints, which bypassed the MFA because the app had session tokens set up for GraphQL, which just didn't go through the usual multi-factor authentication flow. And that allowed access of personal information. So there's not really much more nuance to get into on that one. That's just how the attack works. Sort of a bad idea, I think, to support multiple APIs in that way, because when you have MFA, like when we've seen MFA bypass before, it's usually because of alternative APIs. And that's just this is just another case of that.
I don't know if it's usually because of alternative APIs, really. I mean, because one of the other causes of like MFA I mean, we've seen quite a few causes of it. One that comes to mind to me is just when you're in like those half auth states, like what can you do during some of those like weird authentication states that aren't necessary? Because a lot of things expect like, oh, are you authenticated or not like, are you in this middle
Not like a
ground of like,
tri-state. Yeah.
yeah. And so because of that, I feel like there was like a Twitter, this is a while ago, but like a Twitter MFA bypass. It was on like a password change or something. So you already had to be like authenticated once and then, or yeah, I don't remember all the details on it. Either way, we've seen things like that too. It's not just another API access or just APIs missing it, although APIs missing the MFA check is another common thing. This one I kind of want to call out, like the bug itself isn't super interesting, but whenever you see kind of multiple APIs in use, like when they've tossed on like a GraphQL API, which does happen, like people kind of slowly tend to migrate towards GraphQL. And when you do look at large enterprise apps, you'll often see like they have, maybe they've started migrating towards one tech or another, and you'll see this sort of thing. And I just think it's a reminder about the inconsistency of rule enforcement across them. So not necessarily MFA, but there could be other things that exist also that you could do maybe in GraphQL that you're not allowed to do over the API, or that you're allowed to do over the API that GraphQL doesn't allow. There's a lot of that to keep in mind too, beyond just the 2FA or MFA bypass. And that's more what I want to highlight out of this than just the MFA bypass itself.
Yeah, and that's fair as a reminder. It's basically that it all comes back to that lack of centralization, right? Whenever you start branching out and having these different paths, it's a lot harder to apply fixes across the whole code base or enforce permission models in general, I guess.
Yeah, or remember where you need to update everything. Yeah, a lot gets complicated as you start introducing multiple ways to do the same action.
Yeah. All right, so our last topic is a ZDI post, and it's about a CRLF injection in .NET. And this stems from .NET support for FTP, which, for those who haven't really used FTP or looked at the commands, it's a plain text format, so you have your command identifier, and then your parameters delimited by spaces, and then it's terminated by a carriage return line feed. And when you bulk transfer data, like a file or something, it'll open a separate ephemeral connection for that data using like passfee, and it'll transfer through there. But anyway, problem here is .NET's FTP control stream class just fails to ensure that the parameters that are passed in don't include CRLF characters, or they don't strip them out when building the command string. So as an example here, if you have like a retrieve command that's being built, or readr on an arbitrary file, if that file name includes a CRLF, you can then inject a command afterwards to delete some other file or something like that. So this is something where the impact and exploitability is going to be fairly dependent on how a given application is using the FTP class. because you're not really like privilege escalating necessarily, but you could gain unfettered access to the FTP in situations where an untrusted user goes through an API or something and has control over a file name, but they're supposed to be limited to that built-in functionality and not just have arbitrary FTP access. So in cases like that, this vulnerability could be useful. But that said, you do kind of need that situation where an application is using FTP and you can get some untrusted input into a command there. But yeah, I thought it was kind of interesting just with how, kind of taking advantage of the plain text format of FTP and being able to use that to get control over the file system. I thought that was kind of neat. But I'm not sure how many situations you're going to run into with a .NET application using an FTP library like this.
Yeah, it kind of feels like one of those things where you're not necessarily going to be aware the application is even using FTP in the backend or generating these commands or doing anything like that. Like it feels like most applications, if they're doing, unless it's like a file management thing, give your FTP server, unless it's like really obvious, it can feel a little bit like, you're not going to know the server's doing it. It might be doing it. You have no insight into that. I can't imagine a lot of applications are going to do that. Like your response comes in and it goes straight to FTP, but I could imagine the case where it's kind of more of a second order type of attack where, maybe you upload with your given file name that ends up in database and things get batched and maybe backed up over FTP. I don't know. I could just imagine that sort of second order attack as being more likely than just straightforward it's using it incorrectly and like giving you direct access to it. But what was the case for this actually being exploited? Because this is a ZDI report.
I believe this was just reported to Microsoft as like, because it's a library, right? So they just wanted the class methods for the FTP class to validate the parameters against new line injection.
Yeah, okay. I mean,
I don't think there was a scenario proposed outside of like just the library itself.
yeah, okay, yeah, they do just call it a .NET framework vulnerability, so fair enough. I
Yeah.
just pulled up the CV here to take a quick look, but yeah, okay. I figured maybe they had initially seen this like it was part of their chain or something.
Yeah, no, I don't believe so.
Yeah, I don't see any indication of that, so fair enough. Yeah, I mean, it's going to be hard to know when this is in use, but it's something worth, toss in those new lines, see if you can break things. I could imagine this being really hard to take advantage of, though, because of the
Yeah, you would have to do like that sync to source analysis, right? I think you would basically have to have the code and be able to see like if there's a way that that untrusted input could make its way into FTP classes. But yeah, it's like going at it completely blind and not having the code. I feel like it would be tough to find
yeah,
areas that this could be used.
at least outside of like the really obvious cases, like where it's telling
Yeah,
you it's
like you
using
called out.
FTP. Yeah.
Yeah. All right, so that's all the topics we have for today. So, as always, thanks goes out to everyone who tuned in. You can find previous episodes up on YouTube, Spotify, and Apple Podcasts. You can also feel free to join our Discord and Twitter. Links for those are in the description, and we'll see you in the next one.